There are other types of denial of service attacks. Let's take a look at them. There's sort of a broad term called protocol attack. Now, one can argue that many of the attacks we've looked at are protocol-based attacks, especially the layer 7 and the state exhaustion. They are attacks on specific protocols used on the internet. These protocols, because they're in global use, we're not going to be changing how they work anytime soon. So we would have to have mitigating, compensating controls. Like a lot of folks use, say, Cloudflare or one of these places that are capable of absorbing huge amounts of DOS traffic, sending it to a black hole, and then routing only legitimate requests to the actual target website. So that would be one way of dealing. You have these massive filters in the sky, basically. But we can't go fixing HTTP itself, per se. These protocols that we use, they are inherently complex, and if we try to change them, it could introduce new flaws. Let's talk about something that a lot of folks don't think about, BGP hijacking. Now, BGP, this is a great example of a protocol that could be the basis for distributed denial of service. BGP, Border Gateway Protocol, is the routing protocol used on the internet. What that means is internet routers update each other with BGP. So they say, okay, if you want to get to that whole autonomous system number, meaning that whole network, you go this way. Well, the convergence of BGP is slow. If a route changes on the internet, it's 2 hours before everybody knows about it. It's really slow because the internet is vast. So BGP, if we can manage to send fake BGP updates, pretending we're a BGP neighbor and sending fake updates, we could be sending people totally into outer space trying to get to a route. Here would be a BGP hijacking example. As an attacker, we're pretending to be a router. We send fake BGP routing updates to other internet routers. And those internet routes are now pointing to totally the wrong network instead of the correct network. Here are some real-world examples of BGP hijacking, 2018 and even 2008. There are probably some recent ones, but these are particularly notorious. There was a Russian ISP that announced a number of IP prefixes. That's, like the subnet ID. That's groups of IP addresses used on the internet. The prefixes actually belonged not to Russian ISP, but instead to Amazon Route 53 DNS servers. Route 53 is an Amazon DNS service in the Amazon cloud. Amazon DNS queries were hijacked so that these queries for myetherwallet.com went to servers that were malicious, that the attackers controlled. Now, while users tried to log on to the cryptocurrency site, they were redirected to a fake site where their credentials were snarfed, were harvested. And then attackers logged on as them and stole $150,000+ in cryptocurrency. Then in 2008, this was an attempt by a government that totally went wrong. So the Pakistani government had a telecom called Pakistan Telecom, and they attempted to censor YouTube within the country. They thought they would update its BGP routes for the website, but the routes were announced by Pakistan Telecom's upstream providers, and there went to the whole internet. So suddenly, everyone trying to go to YouTube, they were redirected to that ISP, which meant there was hours-long outage for the website for almost the whole internet, and the ISP got what it deserved, quite frankly. I've had friends who have networks big enough. I mean, to be an autonomous system, you have to have at least 50,000 nodes. Otherwise, you won't get an ASN number. Then friends would call me and say, well, I want to configure BGP so that we choose this route instead of that route. A couple of providers, where we have 2 of them so that we are fault tolerant. And I'd say, you better be careful, because if you misconfigure BGP, you'll end up being what we call a transit network. And this ISP, rather than sending traffic to that ISP along this way, they'll send it through you, which you don't want to have happen. Anyway, BGP hijacking. Then there's a land attack. Now, most machines are not vulnerable to this anymore, but I thought this was really brilliant. You send a spoofed packet to a machine to try to get it to start a session with itself. So very cool. So you send this spoofed SYN packet with the IP being the target itself, the source IP. Source and destination IP both belong to your target. And if it's vulnerable, it'll loop endlessly trying to connect to itself, and it will crash. The land attack. Here is a land attack example. You got the server here. We are going to send these echo requests over to this poor server. We send it with the source and destination being the server's IP. The server tries to respond to itself. We're starting to consume resources. We send even more. It's trying to respond twice to itself. Now we keep on consuming more and more resources, keep on sending more and more of these ICMP echo requests, and pretty soon the server has consumed all its resources trying to respond to itself. Then you've got something called flashing, or permanent denial of service. If you have a phone that you use for business, and it has a policy, a mobile device management policy on it that says X number of bad logins and we are going to brick your device. We're going to send a remote wipe command. And you've had your kid on a Sunday morning trying to log in so they can play a game on your phone and they inadvertently brick your phone. That is a flashing attack. Of course, it's not on purpose. So this is a denial of service that causes permanent damage to a system. It will modify the firmware. We also call it bricking. Like we could send them a fraudulent firmware update, which crashes the BIOS. Kablam. And finally, we have the peer-to-peer attack. If you've ever done peer-to-peer file sharing, maybe you've encountered this, maybe not. We'll take advantage of a protocol that peer-to-peer clients use to cause them to disconnect from their peer-to-peer network and connect to a fake website. We'll attack the DC++ protocol, which is the peer-to-peer file sharing protocol. We'll exploit network flaws, and we can either have them go to something we control, or we can have these file sharing peers together end up launching a huge denial of service attack that will compromise some target website. So that's our look at other types of DOS, DDoS attacks. And now, let's move on.